Hello everyone, this is Rakesh from Bodhee Prep and this will be the second video for number system. I hope you have gone through the previous video on integer, and in that we have dealt in detail what are integers, what are the types of integers, and how many different phrases which which appear in the questions related to integers and how do we interpret it, right? So I believe that we have a fair idea about the integers and their types, etc. Right? Now let us get into depth of number system and let us try to figure out some other kind of numbers, right? So in the number line in the last class we saw that we can plot integers. So I'm just drawing a number line for our reference, and that is, if say this is a number line, so this would be say 0, then this is say 1, this is 2, this is 3, so on and so forth, right? Similarly here it will be -1, here it will be -2, here it will be -3, so on and so forth. Now there are many points within these two numbers 0 and 1, as we can see, right? There are many points, so definitely each point, because these are also the points and they are representing a number which we are calling them as integer, right? We have categorized them as an integer, but there are infinite many points between any two integers. So obviously those points can also be represented in some other way, right? And those points should also be categorized in different ways depending upon what are their nature. So one of the point which I'll be dropping here between say 0 and 1 is the midway between 0 and 1, right? So by the simple logic we can say that the midway should be half, or the half the portion is away from 0 and half the portion away from 1. So clearly this portion from basic logic we can say is nothing but half, because if this is 0, this is 1, then this should be the midway, and midway we know that we represent generally by half. So this is the number which is getting represented, which involve two integers, right? One integer at the above and the other integer at the below. So this representation itself is known as rational numbers. So today's topic is all about rational numbers, right? So what are rational numbers? Rational numbers by definition, if I take the mathematical definition, is nothing but any number which is in the form of P over Q, where P and Q both are integer and the value of Q should not be equal to 0, right? Let me repeat. What are rational numbers? Rational numbers are all such numbers which can be written in the form of P by Q, where both P and Q has to be integer. That means those number has to be taken from here itself in this number line, and the value of Q cannot be 0. Why the value of Q cannot be 0? That we will be dealing at length when we will be discussing divisibility rule. But for the time being, we can say that any number, if I take any number, say 5, you can take your calculator, right? If you have a calculator or mobile, do one thing. Take any number, your favorite number, and divide it by 0 and press enter or equal to sign. What you will be getting? You will be getting an error. Why error? Because such kind of operation, mathematical operation, is not allowed, right? Or we can say that this is not defined. Because of the same reason we don't divide any number by 0, not necessarily for integer or anything. Any number divisible by 0 is not allowed in mathematics, right? Why it is not allowed, etc., we'll be dealing it at length when we'll be discussing the divisibility rule. For the time being, just remember that both P and Q has to be integer, and Q, the denominator part, should not be equal to 0. Okay, so I have said term denominator, so we have to understand that also. So if a rational number is P by Q, so the upper portion, this thing is known as numerator, and this thing is known as denominator, right? So whenever I say denominator, it is, I'm talking about the thing which is below this line, and if I'm talking about numerator, I'm talking about anything which is above this line, right? So this is a simple definition of rational number. So rational numbers are in the form of P by Q. And one more thing is that, can we say that all integers are rational numbers? Yes, we can say. For example, 3 is an integer. So if I consider the value of P to be 3, and if I take the value of Q to be 1 on my own, then we can say that P by Q is nothing but 3 over 1, which itself is nothing but equal to 3, right? Because anything divided by 1 doesn't make any change in the number. It will be the number itself. So this is an integer, and this is in the form of P by Q, which is a rational number. So we can say that all integers can be written in this form, right? For example, the negative value -2 can also be written as -2 by 1 without changing its value. Since I can write this number minus 2 as minus 2 divided by 1 without changing its value, I can say that this is also a rational number by definition of rational number, because rational number should be in the form of p by q. So from here what we have seen is that integer is nothing but a subset of rational number, or all integer come inside a rational number. There are other numbers which are rational numbers, they may not be equal to integer. For example, the number 1 by 2 is not an integer. We can't further reduce it into a single digit, right? So minus 2 by 1 is a rational number, or we can say that all integers, let me write down here, that all integers are rational numbers, right? Do remember this, right? The better way of saying is that integers are subset of rational number, right? Just remember this word subset. Whenever we encounter this term again, I'll be explaining it what are subsets. For the time being, you remember that visually, if I make this is a set of a rational number, suppose all rational numbers I'm writing in this particular circle, right? So this will include integers also, and I'm collecting integers separately within this particular circle. So I'll be having a smaller circle which will be for integers, and all integers will be inside this. And there'll be some other numbers which are not integers, but they will be rational numbers, right? This is how we define this statement that all integers are rational numbers. I hope you have got the definition, basic idea about rational numbers. So let us move further and try to figure out that what else we can do with rational number, or what else we have to understand about the rational numbers. So one thing is that, as I said, that there are infinite rational numbers between any two integers. So can we write down some of the rational numbers between any two integers, right? So let us take a question that we have to write, say 6 rational numbers between 1 and 2. The two integers are 1 and 2. So in a number line, if this is 0, say this is 1 and this is 2, so there will be various rational numbers, infinite rational numbers between 1 and 2. So we have to just figure out some 6 rational numbers between them, right? One way, of course, is that take the midway. If I take the midway, then this will be what? It will be the average of 1 and 2, which comes out to be what? 1 plus 2 divided by 2, which is nothing but 3 by 2. So 3 by 2 is one of the rational number which comes between 1 and 2. But I need 5 more. So what I can do is that, again, I can take the average between these two numbers, right? So if I take the average of these two numbers, that will come out to be 1 plus 3 by 2, this divided by 2, right? Of course, we should understand how do we operate this. If we know how to operate this, we can figure out easily that this will be 5 divided by 2, which comes out to be 5 by 4. So 5 by 4, this will appear here. So this is how we can, so this will be 5 by 4. This is how we can keep on generating more and more rational numbers, right? This is one way. I'll give you a better way of finding, say, n number of rational numbers between any two integers, right? So let's see what is the trick. And that's the easier way than this, because in this case what will happen is that the complexity of calculation may increase. Now what I'll do is that, since I need 6, so what we do is that add 6 plus 1 and make it 7, right? Now I have to write 1 wherein the denominator should be 7. So what should be the numerator, so that the overall value should become 1? It should be 7 itself, right? Because 7 divided by 7 is 1. Similarly, the other integer I have given is 2. So if I want, I need 7 in the denominator. So in the numerator, I'll be getting 14, so that 14 divided by 7 makes it 2. Correct? Now the 6 rational numbers which we can generate is that you can keep 7 as the denominator for all. This is very, very interesting, guys, because this is this will actually increases your this knowledge about rational number. Keep 7 at the denominator and just look at the numerator. This is 7 and this is 14. Start after 7. The next number is 8, then 9, then 10, then 11, then 12, then 13. You will find that if you calculate using the calculator, all these numbers will be between 1 and 2, right? For example, just for the sake of confirming this, 11 by 7, I have a calculator with me. I am dividing 11 divided by 7, which comes out to be 1.571428, so and so forth, right? There are many other digits after this, but this is quite sure that this is 1 point something which is not reaching till 2. So obviously this number will be somewhere between these two. Similarly, 10 by 7 will be somewhere between these two, and all these six numbers are in the form of p by q. Both p and q are integer, and you can see that q is not equal to 0. So all these numbers are rational numbers, and these are rational numbers between 1 and 2. Right? So take as an homework, or you can just pause this video and try to figure out, say, 5 rational numbers between 3 and 4. Just pause the video and try on your own. I'll be on mute for some time so that you can pause. Okay, I believe that you have done that and you must have got the correct answer. If you have used this particular approach, you must have got it, right? What you have to do is that if there are 5 needed, then definitely what you should be doing, you should be adding 5 plus 1 to make it 6, and you want to write 3 so that the denominator should be 6. So obviously here it should be 18. Similarly for 4, if you want the denominator to be 6, then the numerator should be 24. Now all the numbers, the 5 numbers will be 19 by 6, then 20 by 6, then 21 by 6, then 22 by 6, then 23 by 6. You can see that all these 5 numbers are rational numbers which are between 3 and 4. I hope you have also you also got the same rational numbers. I'm not saying that these are the only 5 rational numbers available. There are many other, but this is the quickest way of finding it. Correct? Now let's move to the next thing. So the next important thing is how do we add or subtract two rational numbers? How do we add or subtract two rational numbers? It's very fundamental and elementary, but still I want to touch it because I don't want that you should miss any part within the rational number, and if the similar part is used in the solution of say some questions which appear in CAT, you should not be finding it difficult to understand, right? So I'm taking any two rational numbers. Say I'm taking a rational number 3 by 4. This is a rational number. I'm taking another rational number which is say minus 4 by 5, right? Because it's an integer, so it can be negative also. Now in this case, what I'll be doing is I want to add both these numbers. So 3 by 4 addition of minus 4 by 5. This I want to do. Now clearly in the last class we have seen that plus when multiplied with minus sign, the overall sign is negative. So if I just want to realize this, then this will be plus into minus will make it minus. So overall this should be equal to 3 by 4 minus of 4 by 5. So effectively we have to simplify this. Now here we can see that the denominators are different. So one way is to take the LCM of the denominator. We haven't gone through the topics of HCF and LCM, so I'm just avoiding that. But when we will be reading those, I'll be telling you this other way of adding two rational numbers wherein the denominators are different by taking LCM. Right now, let us assume that we don't know what are LCM. How do we operate it? One way is just multiply these two. Just multiply the denominator. You'll be getting 20. It is 4 into 5 is 20, right? Now this is 4. I want to make it 20. So what should I do? I should multiply it with 5, right? If 3 by 4 is given and I want to make this as 20, I should multiply this thing with 5. But if I multiply only the denominator with 5, it will change the number. I don't want the number should be changed, right? So just to maintain that the number remains 3 by 4 or the value remains equal to 3 by 4, I should be multiplying 5 in the numerator also, because if I am multiplying with the same number in the numerator and the denominator, they will cancel it out. They will cancel each other. The overall value remain the same. This will make it 15, right? The same logic I'll be applying for the other number which is 4 by 5. I want that denominator should be 20. Now what should be I multiplying? I should be multiplying 4, right? And here again I should be multiplying with 4 so that the value remains the same. So here it will be 16. Now what I'll be doing is that I will replace each of these numbers with their corresponding numbers which we have generated, right? So 3 by 4 would be 15 by 20 minus this would be 16 by 20. Now the denominator is same. So what we can do is that we can take the denominator as 20 only, and the numerator will be going with their mathematical operation, right? Which comes out to be minus 1 by 20. So overall the addition of these two is equal to minus 1 by 20. This is the way we do the addition. I have given you each and every step to do, right? Once you become expert into this, which doesn't require too much of time, you can straightforward write the answer, right? If the numbers are easy. If the numbers are slightly complicated, you may have to follow this particular approach, And as I said that there is another approach of taking LCM, that too is used, but this approach is sufficient if you don't want to go for the LCM one, right? Or what I can say that you are good enough to add two rational number, you are good enough to add two irrational number, subtract two rational numbers also, fine. Now this is the most important thing which we have gone through for the rational numbers. Now fractions is another thing which is closely related to rational numbers. Fractions is another thing which is closely related to rational numbers. So let's see what are fractions and what are the different types of fraction and how do we do the mathematical operation related to fractions. So very important topic is fractions, right? Now what are fractions? Fractions are nothing but a kind of rational number only. The only thing is that the denominator is not equal to 1, neither it is equal to 0, right? And they are in their lowest form. So I'm using a lot of terms, I'll be explaining each one of them, right? I'm just writing one example of fraction. Say 3 by 4 is a fraction. It's a rational number also, but at the same time I'm saying that 3 by 4 is a fraction. So 3 by 4 is a fraction in the sense is that we are talking about 3 part out of the total 4 part. If I'm taking anything which is of total is 4 and I'm just taking out 3 part out of that, then that portion is called the fraction 3/4. For example, if I'm taking a circle, right, and if I'm dividing it into 4 equal parts, right, this is a pizza circle and I'm dividing into 4 equal parts, and what I'm doing is that I'm taking out this part and this part, and I'm just eating it. So what I can say is that out of the total I have eaten 3/4 of the total pizza. Why? Because the total is equal to 4. What I have taken out is 3 out of that. So 3/4 becomes the fraction, right? 3/4 is also a rational number, correct? Now here we can see that the denominator is not equal to 1, right? Not equal to 1. At the same time, there is nothing common as far as factor is concerned between 3 and 4, or we can't reduce into lowest form. I'm writing another fraction wherein I can reduce into a lowest form so that you can understand it. What do I mean by reducing it to the lowest form? I'm writing a number, say 16 divided by, let me take some number, say 30, correct? We know that both 16 and 30, they are even numbers, so they are divisible by 2. And if I divide both numerator and denominator by the same number, it will not make any changes in the overall value. So 16 divided by 2 will make it 8. 30 divided by 2 will make it 15. Right? Now can I further reduce it? No. Why? Because there is nothing common between 8 and 15. 8 is an even number, 15 is an odd number. So nothing would be common. So this is the lowest form. This is called the lowest form of any fraction. 16 by 30 is also a fraction, but it is not the lowest form. Although 16 by 30 and 8 by 15 both are equal, but this is the right way of writing any fraction. If the fraction is written in this form, we usually try to reduce into the lowest form so that no confusion is maintained, right? Or there is no confusion. I hope you are getting it right. So I'm writing another number and try to find out the lowest form of it, right? So this is 25 divided by 45, right? Just pause the video and try to write it into the lowest form. Okay, you must have done it and you must have figured it out that both are multiple of 5. So one should do, or one should divide both numerator and denominator by 5. So if I divide 25 by 5, I'll be getting 5. And if I divide 45 by 5, I'll be getting 9. We know that there is no further way wherein we can do the such kind of operation which we just did by dividing both numerator and denominator by 5. So this is the lowest form of the fraction. So I hope you have got the basic idea about the fraction. Now there are various kind of fractions, so let us understand those also. So broadly, fractions are divided into 3 parts. First is a proper fraction. First is a proper fraction. Now what is proper fraction? Proper fraction is all such fractions wherein the numerator is less than denominator. Wherein the numerator is less than denominator. For example, 1 by 2, 3 by 4, right? 7 by 8, 11 by 20. All these fractions, you observe that the numerator is less than denominator. right? And if you see that all these fractions, they are greater than 0 in their values but less than 1. So normally what happens is that the fractions, the proper fractions, are all fractions which are lying between 0 and 1. If I draw a number line and if I put all the proper fractions, they all will lie between 0 and 1. Between 0 and 1 they will be lying. So such fractions are called proper fraction. The next thing is improper fraction. The name itself is suggesting something which will happen just against what the proper fraction is, right? So improper fractions are what? The fractions in which the numerator is greater than denominator. The numerator is greater than denominator. For example, 5 by 2, right? 11 by 2, 13 by 3. In all these cases, you can see that the numerator is higher than the denominator. So obviously, such fractions are called improper fraction. They will definitely not lie between 0 and 1 because their value would be greater than 1. Each of this, if you do the if you take the help of calculator and divide 5 by 2 and 11 by 2, 13 by 3, you'll always be getting a number which is greater than 1. So they will not be lying between 0 and 1. This is improper fraction. Now there is a third kind of fraction which we call mixed fraction. We call it as mixed fraction. Now what is mixed fraction? Mixed fractions are all fractions which are written as a combination of integer and fraction, right? Let me repeat. Mixed fractions are all such fractions which are written as a combination of integer and fraction. I am writing one such number. I am writing a number 2.5. You must have heard this term, right? 2.5. So what is 2.5? 2 itself is an integer and half, 1 by 2, is a fraction, right? In a decimal format, we'll deal decimal in details. 2.5 is also known as 2.5. So both are same. They are being represented differently. This is a decimal representation. This is a mixed fraction representation. So 2.5 is written like this. Correct? Now, what is actual meaning of this? So there is a hidden mathematical operation between these two numbers. We know that this is an integer and this is a fraction. There is nothing written between it, but silently it is understood that there is a plus sign between them. So 2.5 is effectively, we read it as 2 plus 1 by 2. 2 plus 1 by 2. So 2 plus 1 by 2 itself means 2.5, which comes under the category of mixed fraction because it is a combination of integer and fraction. Now, can we write these in form of improper fraction and proper fraction? Yes, we can write it. How? What we can do is that since the denominator is 2 here the denominator is 1 because 2 can be written as 2 by 1, right? Every integer is a rational number. How do we convert every integer as a rational number? By dividing it by 1, correct? So what we can do is that we can convert this denominator of 1 to make it 2. So that for that we have to multiply both numerator and denominator by 2. So 2 into 2 will make it 4. So 4, 1 by 2. Now again the denominator becomes same. So we'll just retain 4 plus 1, which comes out to be 5 by 2. So this 5 by 2 is nothing but 2.5, which effectively is 2.5. All three are same. The only thing is the way we are representing is different. Correct? So this should be clear that anything which is written in this particular format, there is a hidden plus sign between it, right? Now you must have come across in mathematics some numbers written or some simplification to be done, which is written as 2 into 1 by 2. You should not be confused between this and this. If this is written, it is in this particular format. If this is written, this is effectively 2 is multiplied with 1 by 2. So an integer is multiplying with a fraction. This, when you calculate, obviously will get 1 only, right? It is not equal to 2.5. So don't be confused that if something is written like this is equal to this. This is not equal to this. Rather, this is equal to this way, right? So this is mixed fractions. So mixed fractions are nothing but, as we see, they are combination of integer and fraction, right? Now with fractions, normally when the word problem appears, the important thing is the operator of. Okay, usually it appears. So what is this operator of? Operator of in a fraction is what? Let me write them. I want half of 4. I want half of 4. It effectively means that 4 should be divided into 2 equal parts. Each part will become half of 4. So the operator of is nothing but multiplication. For simply very simplified way, I can say that of itself means multiplication whenever the fractions appear, right? So half of 4 is, we know that this will go by 2 times. So overall the value is 2. We also know that if I want to divide 4 into equal parts, each part will be 2 because 2 plus 2 should make it 4, right? So half of 4 means divide 4 into 2 equal parts. And what is the value of each part? So the value of each part is equal to 2. This is the meaning of operator of when fractions are involved, right? So let us take one question and see that how do we comprehend this this concept. So in a class of 40 students, 1/5 of the total student like English, right? 2/5 like maths, and rest like science, right? This is a question. We need to find that how many like English, second, how many like maths, and third question is that how many like science. So we have to find the numbers. If there are 40 numbers of the student, 1/5 like English, 2/5 like mathematics, and rest like science. Now in this case, here we can see that the total number of students is what? 40. What is this statement? 1/5 of total. What is 1 by 5? It's a fraction, right? What is the total? 40. So 1/5 of total is what? They are the number of students who like English. So can I say for English, the number of students should be 1 by 5 of 40, right? And how do we interpret for of? It is nothing but simply a multiplication. So this will 5, this will go by 8 times. So overall, there are 8 students who like English. And you can see that 8 divided by 40 is nothing but 1 by 5 if I reduce it to the lowest form, right? I hope you are getting the connection. 1/5 is nothing but the lowest form, and 1/5 is the part of the total student which like English or who like English. Similarly, for mathematics, we can do the same. It will be 2/5 of 40, which comes out to be 2 by 5 times of 40, which on calculation you will be getting it as 16. Correct? For science, what we can do is that the total are 40. There are only 3 categories. One is for English, one is for maths, and the other is for science. So for science alone, if I want, then it should be 40 minus the sum of these two. Correct? The sum of these two is 24. So we come out to be the overall come out to be 36. So sorry, not 36. It should be 24. So it should be 16 itself, right? 16. So there are 16 students who like science. So this is how these operator of are used in a word problem wherever the fractions appear. So you don't need to do anything. You just have to assume that this is nothing but a mathematical operator multiplication. Right, guys? Fine. Okay, so let us take some more mathematical operation related to fraction, because fraction are very, very important. We must know each and everything related to fraction. Not only we should know, we should be very much expert into it, right? So let us take, I have just taken a few examples. Let us do some mathematical operations related to fractions. So just simplify first. I'm just writing and I'll give you some time for it. We have to do this. Second is we have to do 4 into 1 by 3. Third, we have to do 3 into 5 1 by 5. 4, we have to find half of 2 3 by 4, right? And fifth, we have to find 1/3 of 4 2 by 9. Correct? Just pause the video, take 3-4 minutes, try to solve it, and then compare your answer with the explanation I'll be doing in some time. I'll take a pause for some time so that you can pause your video and do do the calculation. Okay, I hope you have done it right. Now let's check whether you are getting it right or not. This is quite simple. 7 into 3 by 5. So how do we do that? These are multiplication of two rational numbers. They can simply be done as 7 is multiplied by 3 divided by 5. Right? How? Because 7 can be written as 7 divided by 1. So numerator will be multiplied with the numerator and denominator will be multiplied with denominator. This is a simple way of multiplying any two rational number or a fraction. Right? So simply this should be equal to 21 by 5. The same logic should be applied here. The numerator should be multiplied with the numerator and the denominator should be multiplied with the denominator. So overall the value is 4 by 3, which is again a fraction. What kind of fraction it is? Improper fraction. Why so? Because the numerator is greater than denominator. Is it into the lowest form? Yes, because there is no there is nothing common between them, right? Now this, to calculate this, first of all what we should be doing is that this is a mixed fraction. So first of all we should convert this mixed fraction into proper fraction or improper fraction, right? We should get rid of the integral part of it. So we know that 1 by 5 is nothing but 5 plus 1 by 5, correct? So how do we resolve it? We need 5 here, so we should be multiplying 5 here also. So that becomes 25 plus 1 and 5 becomes the common denominator, which becomes 26 by 5. So I'm just writing this is 3 into 26 by 5. Again, 3 can be written as 3 by 1. For that it should be 3 multiplied by 26 divided by 5 into 1, which is 5 itself, right? So I'm just taking help of calculator so that I should not be getting it wrong. So it is 78 divided by 5. This is the overall value for 3 into 5 by 1 by 5, right? Next, half of 2 3 by 4. So again, first of all we have to reduce this. So half of means multiplication and this reduced to 2 plus 3 by 4, right? Again, for 2 plus 3 by 4, what we can do is that we should get denominator of 4 here, right? Here it is 1, so we should be multiplying both numerator and denominator by 4, so this will become 8 plus 3 by 4. Now the denominator is common, so it will be 11. So this can be written as half into 11 by 4. Again, 1 into 11 divided by 2 into 4, which comes out to be 11 by 8. So this is the value of half of 2 3 by 4. Correct, guys? So you can check what is 3 by 4? 0.75 now. So 2 plus, so 2.75. If I divide it by 2, it should be 1.375, which should be the value of 11 divided by 8, which it is. Correct? Now this 2 can be done on the same way. 1/3 of 4 plus 2 by 9. Again, 4 plus 2 by 9. 9 is in the denominator here. The denominator is 1. So what we can do is that we have to make the denominator 9. Both the denominators will be same. So we have to multiply both numerator and denominator by 9. So here it should be 36 plus 2 by 9. So this comes out to be 38 by 9. So this would be 1/3 of 38 by 9, which effectively is 38 divided by 27. Right? So I hope you have understood in this particular video that what are rational numbers. There are many ways wherein what are the ways wherein the rational numbers are written, and we know that there are infinite rational numbers between any two integers. All integers are rational numbers, right? The rational numbers are closely related to fractions because fractions are very, very important. Within fraction, we have understood that what are the different types of fraction. We have understood proper fraction, we have understood improper fraction, we have understood mixed fraction. We have also understood what is the operator of related to fraction. How do we interpret when a word problem appears, right? And how do we do the mathematical operations related to fractions and rational numbers. So these are very, very elementary but very, very necessary. We all should be knowing it by heart, right? There should not be any confusion into it. So in this video, I'll be stopping here only. In the next video, what we'll be doing is that I'll be taking some more examples related to or some more concept related to fractions, and we'll be continuing the concept of decimal, right? Therein we'll also understand what is the relationship between rational number, fraction, and decimal, and how one particular thing can be represented in a fraction also, that the same thing can be represented in a decimal form also, right? So just wait for the next class. And before the next class, I'll highly recommend that you should be doing these two, the previous classes. You should have gone through the previous classes and exercises based on this, which we have put into the courses, right? The link we will be finding in the description, or you will be getting into the WhatsApp group, right? Thanks a lot.